it's Pam Daniels, and I'm here to tell you that you can make anything. Actually, maybe not now, you can't make anything, but we can make things for you. So I'm going to take you through a bunch of things that have been made using a couple of different techniques, 3D printing, laser cutting, and desktop milling. So I'm going to show you some artifacts that have been made using each of those techniques, and hopefully you'll get inspired and think about all the things that you could make too, or because of COVID-19, things that we could make and mail to you. So first off, we're going to start with things that have been made using a laser cutter. So a laser cutter is a technique that uses highly focused beam of light to cut things. So you're cutting with light. Sort of if you ever used a magnifying glass in the sun to burn things as a kid, that's what it does. And there are some things that can be, that I can point to that have been made using that technique. So for instance, this, which was designed as a vase, sort of a vase cover for a pint container, was made on a laser cutter. So all of those cuts through plywood were done on a laser cutter. You can cut textiles on a laser cutter. So this cork bag that I designed, all of the cork parts were laser cut. And then the logo for Urbanite was rastered into the surface of the cork. So you can do two things. You can take the line and cut on a line, or you can say essentially trace across the surface, sort of in a kind of back and forth where light hits only where you tell it, and that's how you get things like logos on a surface of something. Then other fun things you can have. When I was in graduate school, I was a huge nerd, and so I laser cut all my notebooks. So here is a notebook that was made for my classes. I make one for every single class. You can do it even using sort of scrap material if you don't want to get fancy about what you're using for that. Here's another example. So this is a photo frame that was made. So the perimeter was cut, but then signatures were traced and then rastered into the surface of the plywood. There's a back that's solid, and then a frame that has a rectangle cut into it. That was all made on a laser cutter. Even this object here, so all the black parts on here were 3D printed. This is a housing for a blender that I was experimenting with, and the bamboo that's adhered onto the face of here was laser cut. So it's a thin adhesive bamboo that can be adhered to a surface. We wanted to explore sort of a naturalistic feel to a blender, and that's why we chose to do that. What else can I point to? Oh, you can also do things like etch glass. That's a little more complicated. There's only one laser cutter we have here at the Siegel Design Institute that's capable of doing that. But you essentially mount a glass into there, and the glass rotates and it gets hit with light, and you can etch into the surface of glass. So that's pretty fun. I'm going to show you some objects that have been made using a 3D printer, and then we're going to get into the specifics of how to use a 3D printer. So you can do everything from little pots. This is a half-dead succulent in a little black pot that has been made on a 3D printer. There are other objects you can make as well. This one is kind of an interesting example. If you are a Northwestern engineering student, you might recognize this artifact here. I'll hold it on my hand for you. It is a little house that has been part of the curriculum for our engineering students for many years, to build a little foam core house, and I designed it for my fish. I designed a fish house. And so this is made using a 3D printer, and you can see that the 3D printer can do archways pretty nicely. It can also even do some small horizontal spans, which we'll get into a bit later. So that was made, and the walls, I don't think you can see that detail in here, but there's sort of a honeycomb structure on the interior that gives substance to the walls. So they're not really solid. They're designed to reduce material and printing time, and so they'll honeycomb the interior of the walls to be able to accomplish that. Then you can do some other fun things with 3D printing, such as this baby chino rattle, which I made for my neighbor baby. And what I did is I paused the build, changed the filament color to green. In retrospect, I might nudge that up a little bit higher, but I was guessing. And then dropped coffee beans inside the cavity while it was 3D printing and started it again. And so now they're perfectly encased in there. If you look at the top, it says Baby Chino and there's a little smiley face and everything. So you can do really playful, fun things with a 3D printer as well as more practical things. So this blender housing that I'm holding is sort of a mashup of different things from parts from an Oster blender that were repurposed for this and designed to fit this. So this assembly at the top was pulled from an Oster blender, and then all of the black parts were 3D printed. 3D printing, and then the bamboo part was laser cut. So we took existing parts and a motor. There used to be a motor that was working in here from an existing Oster blender, and at one point you could operate this. And then the black parts were printed on a 3D printer, again, to see what did we think about this form factor. And I'm gonna come around to this again when I show you how to operate the 3D printer, but there are support structures in there that had to be pried out. So when you're printing something like this, the structure, you can't really span something as wide as here to all the way over here on air because gravity. So you have to build support structures underneath, and it's a box you tick when you're printing. It's not hard to do, but you do have to pry them out mechanically afterward on the sort of pedestrian level 3D printers. So that is another example. So you can get all fancy and design your own blender elements and incorporate found objects from other things along with 3D printed objects, and then that gets pretty interesting. An example of a project made on Carvey is these cylindrical lamps that Brandon Williams and I designed. So soft metals can be milled really beautifully. So this is copper, and there's a brass version as well. And if you look at how this was constructed, there's a brass sheet that had been perforated with some holes and then formed into a cylinder and then stitched with, I think it's some waxed cord, a little notch indicated there, and then this is the maple base of that, and you can see that there's a really beautiful profile that was used to create the channel for the cord. So you can use different profile end mills. So some have flat bottoms, very squared bottoms, and some have what's called a ball nose that have a rounded end, and that makes different, that has different effects in the wood. So that's what that looks like. So you can cut a really nice square cornered pocket with a straight end mill, and then you can cut a geometry like that using a ball nose end mill. So there's some really beautiful things you can do with Carvey. And even though the dimensions of the bed aren't particularly big, when you start forming things into cylinders, it gets kind of interesting.